Hello, everyone. Welcome to the Tech Animators Workshop. We are, in fact, not animators. We are technical animators, or some of us are technical artists. I don't know. They tend to call us the same or different things at different places. But we pretty much all support animators by building rigs, writing tools, working on pipelines. So we're here today to talk about some of the things that possibly you can do as animators, or if you're tech animators, I guess you can do the same things. Essentially, we set out to get some feedback from the people, from you. And we got a lot of good feedback of things we could talk about. But we ended up settling on workflows for animators that can help them work quicker or work better. And the 5 of us here have compiled small, separate presentations for you all to check out today. Various things that can possibly help you with your own workflows. To my left, we have Izzy Chang, tech artist at Servios. To the left of her, Mike Malinowski, Senior Tech Animator at Creative Assembly. Myself, Brian Viniski, Senior Tech Animator at Avalanche Studios in New York. To the right of me, that's Lee Dunham, Lead Tech Animator at Creative Assembly. And over there on the right, there's Richard Katz. He's a Senior Tech Artist at Blizzard. As you can see, we all have our Twitter handles up there, except for Mike, who apparently had Twitter once, but said that too many people were sliding up in his DMs, so you had to get rid of it. Yeah. So without further ado, let's kick it off with Izzy.
All right. Hey, guys. So I am a technical artist at Servios. I mainly do rigging and pipeline scripting. And I'd like to share with you a technical art approach to communication. So I'm going to give you some strategies on where you can practice to strengthen your communication as an animator with the tech artists on your team and how that specifically applies to solving problems and building tools within game development. This could help you because it'll give you a good perspective on how me and as other tech artists think about solving problems. And in turn, that will help you. So this might seem like common sense stuff, but it's also not necessarily taught in school. It's like a lot of soft skills. And these tips will hopefully help you smooth out communication between you and other departments, including engineers sometimes. So the first thing you want to do is build communication between you and a tech animator or artist is build a common language. And if you build a common language and enhance your vocabulary, you'll have a better way to describe your problem to me. And these are just some examples that I thought of, like gimbal lock, joint orients, constraints. You don't have to be an expert in these areas, but it'll give you a bit of the ins and outs of the rigs and the tools that you're using. And it'll also give you concepts into and insights into how we think about our problems and the problems that we're solving for you. So first thing is you want to build a common language. The second thing is what kind of problem are you having? So you want to communicate to me what kind of problem, whether it be straightforward, like something in the rig is broken, or it can be something more complex, like I have a feature and I have an idea for a tool or something. It would be nice because I want to automate this thing I'm doing over and over, and I don't want it, and it's really boring. Another problem that's really common that I get is, why does Maya hate me? And this is a very hard question to answer because it's very existential. And then another problem also is the problem of miscommunication. Like maybe I give you a tool and you've been using it and it hasn't been doing what you expected. Maybe it's a communication problem where I haven't told you specifically how to use it. So you want to tell me what kind of problem you're having. And then also, along with that, is what is your end result? What is the big picture? For example, you ran into gimbal lock, but what animation are you trying to accomplish? I want to know how you got to this problem. Another example is you might have trouble exporting an animation, but ultimately you want it in the game engine. So why did you run into this issue in the first place? And this prevents me from having tunnel vision into the small problem that's in front of us. Rather, we'll have a bigger idea of the problem we're trying to solve, and I'll be able to think of all the puzzle pieces that go into the ultimate goal. After that, what we want to think about is how you got to this issue and reproducing your problem. Tech artists think a lot about workflow, and we want your workflow to be as smooth as possible, so you spend less time doing the boring technical things and you spend more time doing your animation and your art. And it helps me when you walk through step by step what your process is and how you got to your issue. So let's take an example. So Let's say you have an animation and you're animating a character rig and you have a prop and you want to animate this character with the sword. And you'll say, well, I referenced the weapon and then I constrained it to the hand, but my issue is I want to switch hands. And there's a lot of steps for me to do that, and it's very annoying. It helps me when you go step by step through how you got to your problem, and so I know your process, and then I can start thinking about how to automate it. That's a simple example. Another complex problem is you have a feature, and you say, oh, like it would be really nice if I had these steps. You know, I wish those steps were already in place, and so it would be nice for me to know what your ideal situation would be for a new feature or a new tool. So this is where it gets more interesting. After you've communicated to me your problem and showed me your process, that's you. No, I'm kidding. Now this is where it gets interesting, because now we're going to start working on a solution together. And I'm going to ask myself, what is the best approach to building a tool for you? And in order for me to start thinking about that, start answering that question, I'm going to want to know a couple things. I want to know what parts of the solution are most important to you. What is wasting the most time? And is there something that you want fixed first? Or what is the most important thing to be fixed? Because I could totally guess on these things, and I could get it wrong. So, for example, I could guess, oh, you're animating this character with a prop, and you're switching from one hand to another. But then I realize, actually, the most painful thing for you is switching spaces. And you're not actually switching hands that often. You're actually doing some more space switching. So I might have written the tool for switching hands, and that might not have been that big of a deal to you and not that useful. So after we get all these ideas in place, together we'll agree on a first pass of a tool. And this is really, really important, because we'll agree, OK, I'm going to give you this bare bones solution to a tool, and you're going to tell me and come back to me after you've used it a while how it's going. And your needs might change over time. And this is the process of reevaluating your needs, and if we need to add more or less to the tool, because it might turn out you might not need the tool anymore. So during this process of evaluation, on top of that, I also want to think about how this tool can solve other problems that might arise, or if we want to keep it more narrow or broaden it out. So that's also something I keep in mind with this cycle. So after that, maybe we've narrowed down what your issue is. Maybe we figured out what's important for you to fix. And now I want to make the tool as easy for you as possible. And this kind of starts with, like, what is your preferences for UI for a particular situation? Like, do you like buttons and windows and sliders, or do you like something in the viewport? Back to the prop example, maybe you like a button click that will attach the prop to the hand or something, or maybe you want a physical curve in the viewport that you can move around, or maybe you like an attribute in a channel box. I usually also iterate on this and work with you on this, and we keep it really collaborative, so it makes it the most useful to you. And another really, really important thing is that I want to make sure I'm compartmentalizing these features in the tool properly, so that you're not being bombarded with so much information. Like, imagine if you had a window and a bunch of buttons, and you're like, oh, I don't know, like, which buttons to press, right? So I want to make sure that all the relevant information for your task is in front of you, and if you need to switch context, then that's also available. This is actually the first thing I do before everything else. Is I try to figure out if a solution already exists online, and I'll Google around and use YouTube. This is something you can try yourself as well. And I also look on Creative Crash to see if somebody posted something. Creative Crash is a huge database of just user-created tools for Maya and all these other things, and you can download it. Usually they're free. Sometimes you pay. You can also go on techartist.org. There's a lot of people who post their problems, and then tech artists will go and basically solve them sometimes, and it's awesome. And then sometimes it's as simple as going to Autodesk and looking up the documentation and seeing if you missed a checkbox somewhere. But no matter what, in order to build a solution that works for you, communication is key. And to recap, the first thing you do is build a language. The next thing you do is communicate your issue, whether it be simple or complex, or if Maya hates you. And then the next step is to walk me through how you got to your issue, or how you imagine your solution to be. and then telling me what is most important for usability and how much time would be saved, and we go back and forth on that, and there's a cycle to that. And then telling me your user interface preferences and how you imagine the tool to be, like how you want it to look, and then also seeing if a solution exists online. So thanks for listening. That's me. And I'm Twitter at Izzy C. Chang, and visit me at my booth.
Awesome. Thanks,
Yay.
Izzy.
Yep.
So, Mike, you're next.
Woo!
Do some seat swapping first.
Musical chairs.
Musical chairs, yeah.
Do we have music that we can play? No?
No dancing, no dancing.
All right. All right. Take it away, Mike.
Okay, so I'm Mike, tech animator at Creative Assembly, and I'm going to do a dabble into space switching. So, yeah. Okay, yes, so, thank you. Yeah. So I'm going to dive into space switching a little bit, because if you don't have a dedicated TA, that can sometimes be a little bit daunting. But it's not that scary when you understand that everything in Maya, when you're translating an object or rotating an object, you're always dealing with an offset from whatever its parent is. So when you've got a hierarchy of nodes in the outliner, whenever you're translating something, you're always working with the offset from whatever the object is above it. And that's true even when you constrain something, right? So if you ever look in the node editor and you see a constraint and you'll see it feeding in from the world space of an object, it's ultimately only ever feeding into the local attributes of the object that's being manipulated, if that makes any sense at all. Hopefully it does. But to give it a bit more context, and if I hit space, they'll play these videos in the wrong order, I think, so I'll click the button here. This is a pretty straightforward example of space switching, and it's an animation by Dan Marsh, who's a really awesome animator on Halo Wars 2. But you can see like this guy here is holding a weapon in his hand, so the weapon is animating relative to the guy's hand. He gets shot, he drops the weapon, and from that point on, that weapon needs to move relative to the world and not following the guy anymore. So that's a really common thing for combat animations. And then this one's the same thing, but a little bit more complex. So one of the guys is holding a big hammer. So it's moving relative to the hand of the first guy. He gets kicked, so he throws a hammer in the air. The hammer's spinning around, so it's got to move in world space again. But then the next guy catches it, so suddenly the hammer has to then move with the other guy's hand. So it's then traversing through 3 different spaces. So we're going to have a quick run through. So we'll look at 2 ways of dealing with space switching. So if you're an animator that's a little bit technical or doesn't mind dabbling with a bit of script, then that's cool. And we'll go through a few approaches there. And then there's a whole bunch of off-the-shelf things as well that you can just kind of pick up and utilize if you don't want to dive into any code at all. And I'll warn you, when I'm a technical animator, it's less animator and more technical, so you're not going to see any great animations here. But there we go. That's an absolutely fantastic showreel piece. But ultimately, so this one is, the approach here is more of a changing the space to move something from a completely different pivot. So this is not that dissimilar from what Richard Lyko showed at GDC 2014, whereby you take an object and you've got an F-curve and it's relative to that object space. And then we create a new object from a different pivot. So we move it off to the side here if we want to pivot the cube from its edge. And all we're doing in this script is essentially taking the world space motion of the cube and we're mapping that to the new control. And then we're constraining that cube to that control, and then you can start to animate and adjust the curves based on wherever that control is. So it's a really nice way of changing space. But you're kind of, the downside here is you're changing the space throughout the entirety of time. So it's really good if you just want to work in this space for this period of time, and then you're kind of completely switching all your curves to work in a different space. So that's kind of cool. It's good if you want to switch spaces, but not animate the switch. But it's a really nice, the nice thing there is it works with anything, right? It doesn't have any preconception of what your rig looks like or anything else. And the script itself is on GitHub. I haven't got the link there, but I guess we can post that at some point somewhere.
We're going to hopefully find a way to put them somewhere for everyone, all of our presentations, if we have scripts to show off.
Awesome. Yeah, and then so the next one is, again, a really awesome animation. It's a bit more advanced. There's more than one object animating, which is cool. But ultimately here we're going to try and animate the space switch, right? So to start with, we want to have a cube that moves with the red circle, and then at some point in time we want to be able to move it with the blue circle. But ultimately, when we switch that space, we don't want to have, we want the ability to not affect the animation before the switch. So for that, we have, so I'm animating the cube, and when we're space switching to an object here, we have to have one expectation, right? The cube we always want to animate, so we can't constrain the cube in this situation. So we have to have a node above the cube. So in that case, in Maya, that would be a group node. In Max, maybe it would be a dummy or something. The concepts are the same. And all we're really doing here is we're constraining that group node instead of the cube. And we're keying the constraint on and off. And then all of our F-curves are relative to that group node. And then when we space switch to the blue node, all we're doing is we're taking the world space transform of that group node, and just before we constrain it, we store that matrix, and we then add the constraint, switch the keys, and then reapply the same relative position, and then you can keep animating. The downside here, of course, as we can see, is you see the switch in your F-curve editor, so it makes it very easy to know where your switch is, but it can be a bit jarring to work with the curves. But you can kind of get around that if you want to start exploring this, then grab this script off GitHub, and you can start to play around by pushing those curves onto the attributes of the controls or adding another buffer node and whatever else. But if you're interested in scripting a little bit, consider these scripts as kind of a starting point to kind of explore and dabble with. Is it space? Cool. And if you don't like scripting at all, and not everyone does, I don't think Lee does, given the quality of work, but but there's a bunch of off-the-shelf tools, right? So there's the two at the bottom, which you can just pick up and they just work. And if you're interested in finding a more technical route, then there's the EXO tools, which have bidirectional constraints and stuff, and they're really nice as well. But yeah, hopefully that kind of gives you something to go with.
Cool. And
Awesome.
I'm not going to switch chairs with you because this computer's right in front of both of us. Thanks, Mike, though. That was a burn, though. Why'd you hurt Lee so hard?
Always.
Words hurt, man. Words hurt. All right. So I'm going to talk to you all about simple retargeting using HumanIK and Maya. It's something that I use a lot at work at Avalanche on a pretty day-to-day basis. Or rather, the animators use it because I have some setups for them to go along with it. And hopefully I can share some of that knowledge with you now, and you can get retargeting going anytime you want. All right. So I actually wanted to discuss this particular topic because I've been utilizing it for years now. And it's something that a lot of major studios do. I know Mike and Lee use it at Creative Assembly. And it's become, right? Yeah? You use it? Yeah? Yeah? Okay. Yeah. It's become a great way to share animations between rigs for fast prototyping. It can save a lot of time if you just need to get something like a quick walk cycle or even something more intricate on your rigs. And not a lot of animators actually think to use it or are even aware of how it works. A couple terms, because I'm just going to use the quick ways to say these things. HumanIK, I'm going to call it HIK. And when I talk about character definitions and characterization, they're kind of one and the same. They both mean pretty similar things. You essentially characterize the character definition. So why do we use this? It's fast. We can have characters set up pretty easily and within a few minutes. It's really simple. Once you have your characters set, you can easily retarget and transfer animation with a few clicks of a mouse. And it's really powerful. You can also use HIK at a very basic level for quick work, or you integrate in, or you can integrate it into more of an advanced pipeline for more accurate and robust workflows. There's two really important assets or facets to your HIK setup. That's the character definition, which your source character needs to have, and the custom rig, which the character you're applying animation needs to have. If you're not aware of where HumanIK exists in Maya, you can find it by going to the rigging toolbar, looking for HumanIK at the bottom there, and then it pops up on the right in your dock. This is what the character definition window looks like. The actual process of characterizing your skeleton is pretty simple. The only tricky part will be if you're using a rig that you snagged from the internet, such as Stuart. I think a lot of animators have used this rig. It's free online from Animation Mentor. So yeah, I'm going to use this just to quickly show you how you can actually characterize Stuart, since he is a found rig. You're going to go through and you need to access the joints. A lot of found rigs actually have a show skeleton toggle somewhere on the root control. Sometimes you might have to dig for it. But once you have your skeleton, you can go ahead and start to characterize it, where all it entails is selecting your joint, right-clicking on the appropriate match within the character definition tab, and then it's selecting assign selected bone. We only need these particular joints on the left for a valid characterization, but I also recommend adding the neck, shoulders, and at least 2 more spine joints for better results when you're retargeting. The whole character definition is pretty much an essential step if the animation on this rig is going to be your source. But if your rig is going to be the one that is having the animation applied to it, you don't really need to worry about this step at all. You will have to worry about the custom rig, though. While it does actually need a characterized skeleton to work, I found there's a little trick that you can use to save time from going through the whole process. If you go and create skeleton from the HumanIK menu, you get an already T-posed characterized skeleton. You can scale that down to roughly match your character, and you're actually all set to go. You can hide the skeleton, and it sort of acts as a dummy. Once you have that dummy skeleton, you can actually hook your Maya controls up to the custom rig. The process is identical to the characterized setup, in that you're picking your controls, right-clicking the appropriate node, and then selecting assign selected effector. One note, though, if you're using FK, you need to set all 3 arm or leg sections to each FK control. But for IK, you only need to set the pull vector to what would be the elbow, and the actual IK arm or leg to what would be the wrist. And also for controls that have the channels locked, such as the head having translates locked or an elbow, you'll get a warning about it, which you can say ignore locked, and it should do the work for you. Well, once that's done, the hard part's actually over. We can actually start applying this to everything we just did. Here I grabbed a civilian walk from Just Cause 3. We actually characterize all of our Maya rigs by default in order to take advantage of this process whenever we want. So all I have to do is bring in that Stuart rig that's now has set up custom rig, set the character slot up there, and then set the source to civilian, and you're done. One thing to note, Stuart here isn't actually following one-to-one with the source, simply because HumanIK is calculating that retarget. And because he's a little shorter than the civilian, he's actually following slightly behind because his footsteps are matching up, and his retargeting is actually, rather HumanIK is doing the retargeting for you, the math for you. And just as a further example, this isn't just good for basic locomotion or simple animations. You can actually use this to retarget anything, such as this getup that we have on an enemy soldier. All right, quick note about using IK or FK. IK arms and legs will work pretty well if your characters are similar in size. And obviously, you might prefer this, especially for legs when you want to bake down to IK and work from there so you can plant your feet. But FK retargets much more accurately and is really essential if your characters are very different in size. Now, when it comes to an IK versus an FK spine, even if your 2 characters are exactly the same size, your IK spine is probably going to freak out a little bit. Here we have Deadpool, which I know a lot of people like using Keel Figgins' rigs. Yeah, so Deadpool is actually set up with only an IK spine, and this is the result we get. He's actually a lot smaller than Rico there. And the IK spine doesn't really work. The arms and legs are working because we have those in FK, but the spine there is getting translated out of nowhere simply because of the size difference and the translation values that it actually is taking in. So what do we do in this case? Well, here's another hack you can use. I created 3 locators like an FK spine. The base one is getting constrained to the cog, the center of gravity control. And then the middle and end ones are actually children of that in succession as if they're an FK spine. And then we actually just have the IK chest follow the top control by parent constraining it. And now we have an awesome Deadpool walking with Mr. Rico there. This looks pretty sweet. Yeah. Thank you. Thank you, Mike. No thanks to you or you. Or you? No. Now, for some advanced concepts that we can actually apply to more advanced pipelines, this is an example that I have from Avalanche. Every skeleton is characterized, like I said before, and we actually get 2 rigs per unique skeleton. So our auto rig tools will spit out both a Maya rig and an HIK rig. And those get checked into Perforce, so animators can use them. We have animators that actually love using Motion Builder, so they will take that rig, the HIK rig rather, and put it into Motion Builder. Others love using Maya more, so they'll use that in Maya. But either way, we can actually transfer easily using these rigs. The trick that we use is Maya animation gets hooked up to the HIK rig, that retargets, or that gets baked down, and then we bring that into Motion Builder if we want to, or we can use that and retarget that to a separate, a different rig rather, that's different sized, and then once that's retargeted over to the HIK rigs actually have Maya controls underneath that mimic exactly the same controls as the FK Maya rig, and then that gets baked down and brought back in. It's a little bit of a long process, but it does work pretty well once you have it set up in an automated system. So I'm actually done. That's it. You can follow me on Twitter. I'm at Tech Animator. I definitely stole that. I guess I have a lot of pressure on me to have that now. But yeah, I'm done. Lee, you're up.
Awesome.
Yeah.
Okay, I'm going to have to switch seats if that's all right. Yeah, thank you. Oh, how are we going to do this without looking awkward? Yep. Oh, nope, 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 yep. Okay. Don't know how that looked. Hi, so I'm Lee Dunham. I'm the lead technical animator for the Total War series at Creative Assembly. I'm going to try and show one way, an approach to automate follow-through on animations, and should really work on most rigs, if any rigs. So we'll give it a go. So what is follow-through? So it was follow-through and overlapping action is one of the 12 principles of animation, developed by 9 old guys, and it helps convey weight and believability to an action or motion by replicating the behavior we see every day. So imagine like a bouncing ball or a swinging arms or a pendulum or something like that. So it's similar to anticipation, but it occurs after the main action. That's Wikipedia, so that was quite handy. So why automate? What is automation? Okay. So automation is to try and let the computer to do the hard work. Typically, it means the repetitive and predictable tasks. Sorry. Sorry, guys. The repetitive and predictable tasks, if you don't have to do them, try and get the computer to do them, if the computer can do them. Follow-through behavior can be described in math. It's quite predictable, and computers are good at math, so try and do it that way. And why automate? Essentially, you want to save time. If you can save time, you can focus your time more on the cooler shots, the interconnected actions, or cool stuff, really, and then that way you save money. Okay, so how do we do this? We're going to go through a breakdown of a few videos, each one describing a particular section that would hopefully help describe the process and why. So first one, I will have to click. And so the animation is done by Matthew Lewis for Total War, Warhammer 2. We've got Coxagore just doing a 90-degree turn here. So as you can see on the hand here, the animation is in IK on the arms, and we just want to try and get some more overlapping action at the end of the animation. So just to say, the weapon itself and the left hand is constrained as well. So we just need to edit this one right hand control. You can apply this to other things anyway. So what we're going to do in this example, we're going to use a jiggle deformer. There's plenty of ways of doing this: particles, N-hair, N-cloth, so on and so forth, or expressions. The jiggle deformer will apply to mesh. So what we want to do is, see if that works. Yep. What we want to do is create a polyplane, and this is just to create something really simple and easy to follow. And we create the width and height of whatever to scale it up to, and we make sure there's only one division on each, and then we just do a parent constraint without any offset to the control we want it to be added to, and we just check to make sure that that's following through. So it should be fairly easy to see on that. And then what we want to do from this is we want to take it down and add a jiggle deformer to the polymesh. The reason we're doing this is because we want to have the end result. We want to be able to see the end result. So as we first apply it, you can see it's quite jittery. It's quite jittery because of the default settings. So as I mentioned, it was a mesh deformer. So we want to then change the jiggle properties. So we go to the shape, and we go to the jiggle deformer, and we change a couple of the settings. If your character's between 1 meter to 5 meters tall, these settings may work. So that's force along normal 0.5, along tangent 0.5, stiffness 0.1, damping 0, jiggle weight 0.8. It's fairly straightforward to see, but you can see the results a lot closer to what we want. And then we want to see how this applies onto the end result at the end of the day. So playing back the animation, we can see it's quite useful. Now we want to bake this deformer behavior back onto the transform of the control. To avoid any cyclic dependencies, a cyclic dependency is when you have one thing influence another, which then influence the original object in some way. Maya doesn't handle those well, so we need to break that cyclic dependency. So we delete the constraint, but before we do that, we bake the translate and rotate channels of the polyplane and then delete the constraint. So now the polyplane has a jiggle deformer and the original motion. So after we do that, we then apply a, 1 second going through. Oh yeah, so just confirm, as I mentioned before, the jiggle deformer applies to the geometry onto the mesh. Now that's not useful to us because we want to apply back onto a transform, and there's quite a big difference. So in order to apply the jiggle deformer's behavior back onto the transform, we create an n-hair object and create an n-hair onto the polyplane, and we do a u of 1 and a v of 1 and a hair curve of 1, and we delete everything but the follicle. Now the follicle is quite clever in the sense that it will then provide a transform object that's locked to the face of the geometry. As we can see in the video here, it's popping out. That's what we want. What we don't want is the nucleus, we don't want the hair shape or the hair system or the curve itself. We just want that follicle, because that's what we're going to be constraining that hand back to. So after we've got that, yeah, so now we constrain the hand to the follicle, and then what we can see there is the behavior of the jiggle deformer right back onto the right-hand IK control. We do a constrain with maintaining offset, just in case there's any differences between the two. And once we play back, what we should see is now we can see that jiggle deformer applying directly back onto the IK control. But what we do see is a little pop as we're coming along. Now, because it's live, what we can do is we can then still modify the jiggle deformer parameters. So what we're going to change is the weight to about 0.6. In this animation, it works at least. So that reduces the jiggle deformer's influence on the mesh, which is on the control. So then the pop disappears, but it's an animatable channel, so we can then animate it back up. Once we're safe away from the pop, or in areas in which it doesn't necessarily work, we can then raise it back up in order to get that behavior back again. And that's exactly what we're doing here. We've taken it down to 0.6, bump it back up to 0.8, and then right by the end, we're doing it to 0.9. Let's just get the maximum amount of settle from there. So you can see there, the results are looking a lot nicer, and we're getting something for free. Okay. So on the last one, is that just the same video? Yeah, that is the same video. Apologies. So after we've constrained it up and we've changed those parameters, because we're dealing with dynamics, you may get a few issues, whether it's to do with jitter or anything like that, if you're doing any viewpoint 2.0 vertex caching. So what we can do is if we do a geometry cache on the polyplane, we can eliminate any issues when we then try to bake the animation back down onto the control. It's not always needed, but if you do follow this process step by step, you won't encounter any issues in this circumstance. I mean, there's always going to be particular issues that might prop up, but generally this is pretty safe. So we're doing the geometry cache on the polyplane, which means that then as we do a playback, we're no longer playing back live behavior on the deformer, which means it's a lot safer. So then finally, we can get a clean result when we go through, and there we go. Go through and bake out, because the IK control is constrained, we then bake out the animation on the translate and rotate channels back onto the control. And finally, we can go through and start doing a cleanup. And cleanup just basically means delete everything that wasn't in that was created. So that'll be the plane and the constraints and jiggle deformer. And then finally, you can see the end result. Again, things aren't always going to be perfect, but it should provide you with some free animation. And again, you don't have to apply this to one object. And this is just to show a difference, the example of what it was before and after. Sometimes it's really useful, and again, it's for free. This won't just work on an animation of, say, 90 frames. It could work on an animation of 100, 1,000 frames, and you can key the weight up and down as you're going along. So it is very, very handy. How can we take this further? As I mentioned, you can apply that to either different controls, pole vectors, IK handles, or anything like that. But then you can also automate it, which is exactly what I've done here on this example. First, we go through and we will grab the, so we've got the original animation as before, grab the pole vector control, and we will then do a setup. And the setup does everything, creating the polyplane, the jiggle deformer, and setting the defaults. And that allows you the chance to then animate the weight, as we've done before, just to avoid any pops or anything that you don't necessarily want. It's important to be able to do this, because if you just run the same results, the same value all of the time for weight, your behavior is not necessarily going to work for everything. So at least if you give yourself these controls, it should help. Finally, from that, after we're happy with the weighting, we go through. Sorry, I'm a bit ahead of myself. We go through and then we can bake this animation out. And this does the same thing as before. It caches the geometry out just to make sure you get a consistent result. Caches the geometry on the polyplane, and then it bakes out the animation on the IK control and deletes everything from the setup, which then gives you some free overlapping animation. As I mentioned, it could be on an animation of 45 frames, or it could be an animation on 1,000 frames. And again, just to show the result, the difference between the two, from the original and the that one. So, yeah, hopefully that's all right. See how it goes. So I think, yeah, Rich. Yeah, I'm done. Yeah.
Yeah, I'll take it. You want to grab the one that's next to the computer? All right, thanks a lot, Lee. Last one on the list is Rich. No, just sit there. You can sit there.
I can sit there.
You can sit there.
Oh, thank you.
Yeah, sit right there.
Microphone. Hey, what's up, everyone? So I want to talk about something that I know everyone's interested in. The rig, the animation rig. It's a user interface for the animators. So I'm on the World of Warcraft team at Blizzard. We have a ton of animators who all have different preferences. It's a large, diverse team. Large, diverse team. All right. I've had some animators show me some cool looking rigs they see in videos, but when we actually build it and they start using it, they end up not liking it as much in practice and switching off all the features and just animating in straight FK. Look at something like Microsoft Windows. There's a set of familiar and shared interface elements. How many UI elements can you name just in the simple Explorer window? There's a combo box, a menu bar, large graphic icons, small icon buttons, and a tree view to indicate a hierarchy of files. When applications adopt the standard operating system UI theme, the interface becomes somewhat invisible. But when you come across an application that tries to change it up or try something cool, most people look at it and just throw their arms up. They have to stop and think about every little thing they do, and that could potentially slow them down. Working with such a large team of animators on rigs that are used for many years and shared across multiple characters, our rigs tend to gravitate towards the lowest common denominator that works for all of the animators that will be using it, and that's not always a bad thing. So I wrote up a survey and sent it out to the animators on my team. I tried to write the questions in a way that didn't lead their answers. And I've included some comments in the slides, but I'll try and summarize it as best I can. I let them answer anonymously, and most did. These are the animators on World of Warcraft. These are what they told me when I asked them these questions. And here are the results. So I asked them how often do they download free rigs from the internet, just to try them out, see what's out there. And their answers were somewhere between a few times a year and once every few years. I asked them, have you ever suggested features to your riggers based on feature you've used in a non-work rig? Most of the answers were along the lines of, how can we improve the existing rig rather than, I have this radical new idea for a rig. The responses were focused on improving the animator's workflow within the confines of the current pipeline. I asked them, was there something you missed from a previous rig you've used? Some responses here, like GUI pickers or dynamic constraints, are much more feasible on projects where there's only a handful of characters to worry about. Our project has literally several hundred character rigs spread out across multiple generations of iteration. I asked, would you find it difficult to animate an IK limb with a twist attribute instead of a pole vector control? A little more than half were emphatically against the idea. But one respondent said that they would actually prefer it. There are definitely a variety of opinions on any aspect of controls on a rig. How would you feel about controlling the IK angle with a rotation control rather than a traditional translational pole vector control? Half were still hesitant to work with an IK limb without the translational pole vector, but the other half were at least willing to give it a try. What kind of control pickers do you prefer? This was surprisingly evenly split. About a quarter wanted to be able to pick controls from a list of control names. Another quarter wanted a paper doll visual picker UI. And another quarter didn't want a UI at all. They just wanted to pick controls directly in the interface without a standalone window. So I asked a few similar questions here. This question was meant to ask, in the case of a toolbox panel windows, would they prefer multiple separate windows floating around or everything in one panel? And about 3/4 of them said they preferred one floating panel. So this question is, okay, if there was one floating panel, do you like the ability to collapse and expand individual sections of the panel? And most respondents like being able to hide things that they're not using. I think the key to this is that the panel remembers each user's preference and restoring the last state and position when they reopen the panel. And finally, another similar question, but I'm asking about animatable attributes on the rig itself. Unsurprisingly, almost all preferred rig functionality distributed logically across the rig. So hand attributes were on the hand, and head attributes on the head, and so on. Do you find it difficult to animate with an unfinished proxy model? The animators were unanimous in their appreciation. Oh, wait, what? Oh, do you like color-coded controls? That was that question. The animators were all right, sorry. The animators were unanimous in their appreciation of controls color-coded for the right, left, and center to better navigate the controls visually and be able to make associations between the controls in the viewport and in the picker by color. Some of the responses did caution about using too many colors, however. Did you find it difficult to animate with an unfinished proxy model? About half said it wouldn't be difficult, but a couple of the respondents did admit to wanting to see accurate shapes and silhouettes. would you use an eye aim control? Almost all responded that they would use a control to aim a character's eyes. Interestingly enough, we have this functionality in our rigs, and I rarely ever see it used. It goes to show that the premise that the animators sometimes don't know exactly what they want. So ribbons are these fancy tech that look awesome in demos of stretched out plane warping and contorting in a Vimeo video. Am I allowed to say Vimeo on Twitch? I don't know. But at least half of the animators answered that they just want FK controls that they can pin in world space and not have to worry about counter-animating unexpected effects further down the chain. When switching IKFK modes, do you like it when the inactive controls auto-hide? And this was split. Common response was that they like to be able to see both at the same time, especially if they're jumping back and forth within a single animation. I asked them what their biggest pet peeve in rigs was. And when you list them out, they seem pretty obvious. Wasting clicks, which is an interface problem. Too many visible controls. Information overload, which is an interface problem. Inconsistencies in the interface. And sluggish playback and responsiveness. Finally, I asked for any additional comments about rig usability. And there was the acknowledgement that building rigs that makes everyone happy is hard and a lot of work. So I summarized, and I included some of my own observations as well. What we really need to do is document and instruct and educate the animators on how the rig is supposed to work, how to best get the results that they want out of the rig, and we can't rely on an animator discovering features on their own. And for animators, they need to keep asking for things that make their life easier. Keep asking, even if the answer is usually no. One of the things that I keep thinking about is, in order to keep a rig lightweight, better playback speed, we should consider offloading some rig features into standalone tools rather than integrated rig components. We should allow for animators multiple ways to do things as long as they don't conflict with each other. Simple test cases. Oh, how do you go back? All right. Simple test cases can, in theory, demonstrate new features. But until several animators use it in production and agree that it's a better way of working, new features can't be considered successful. Ultimately, we'll continue the constant search for the right balance of enough information without providing too much information and overwhelming the animator. That's it.
Do we have questions? I think we might have some questions. Yeah, we have some questions coming up. Here.
A bunch of questions.
Oh, wow. Oh, hey, Lee Dunham, you're at the top. At Niels Dinkelar?
Okay.
Yeah,
Yep.
it's for Lee Dunham. Do you want to grab the mic over there, Lee? As a student that dreams of working at CA one day and being able to work with a Vicon Blade studio, what kind of skill set could I try to learn in order to be hireable?
Okay, working to be able to work on. Okay, so to be able to work with the Vicon Blade Studio, depends whether you're working more towards technical animation or animation itself. Generally, just having an understanding of how the animation works, how retargeting works, especially when it comes down to mocap data. You know, we do have our own mocap studio, which is really, really useful for animators just to be able to jump in the suit, test out a few ideas, and then bring that data over. But the understanding the limitations of the system, as well as being able to what happens when you transfer this data across, is really useful in order to be able to make the most of the data that you have. So having an understanding of that is really desirable. Having an understanding in general of how games work and how you implement animations into game engines, limitations again, really, really useful across the board. But just having if it's animation, just having a good animation showreel, some mocap examples of cleanup, as well as an understanding of how to implement animations into a game engine is absolutely really beneficial in a reel that we look for.
And I'm going to let you answer this one too. Hopefully it doesn't get you in PR trouble. At VR Game Zone 1 says, any chance of alien isolation for VR?
I'm on, safely answer, I'm on Total War. I don't know. I don't know. Sorry.
What about Mike? Does Mike have an answer for that?
I'm just going to hide under the table.
Mike's going to hide under the table, apparently. All right. I guess some of these are possibly general questions. Maybe does Mike want to answer this? At Niels Dinklar again. Could you describe what your motion capture process looks like? Is that a Mike thing?
Yeah, we can take that. So we use, on Halo Wars 2, it's a mixture of keyframe and motion capture. And as Lee said, we've got a in-house mocap studio and a really awesome mocap TD that runs that. And it really enabled our animators to just kind of go over to the mocap studio and experiment and play with different motions without having to know up front exactly what it was, or they didn't have to pre-plan every single action that they wanted to do and worry about every single second. They would then shoot all of that, and our mocap TD would utilize Motion Builder and essentially give us a big library of all the motion data, which would come through as FBX, and using a retargeter that I think Lee wrote. I certainly can't take credit for that. Yeah, which one? The one that works. So it's definitely not mine. But we have a retargeter which just takes an FBX file, FBX skeleton, and maps that onto our FK and IK controls. And the whole process meant that as an animator, you go to the mocap studio, you do the shoot, and normally within a day you'd get your nice library of mocap files, and then you'd just run those through the retargeting tool, and you'd have that data then on the control rig in Maya, and you just kind of pick which ones you want and start working with the animation in Maya pretty much.
All right, I'm going to throw this one to Rich, actually. This is from @abagofcandy. What are some common frustrations when dealing with people who don't understand rigging?
Don't understand rigging.
Like, let's say you're working with an animator that doesn't necessarily understand the rigging process.
It's not so much the animators, but sometimes producers and designers. They tend to think of an animation rig as just some skeleton that you put some geometry on and then you slap it in the game. But there's, we have systems for building controls and guts of the rigs to make them work and to make them, and tools we have to maintain to get them to export correctly, and all sorts of steps along the way. And I think that's the biggest thing. For animators, I think I'm used to working with pretty, not technical, but technical enough that they know, enough about it that they don't really wonder about what's going on.
I think today's animators are definitely more well-versed in the technical side of things.
One thing I like to try and point out is no matter how much an artist or an animator wants to work on their craft and the artsiness of what they're working on, they are in the end software developers, and they work at a software development company, and they have to keep in mind that there's a bunch of things they need to learn technical to get their products into the game.
Cool. Yeah, and I definitely get frustrated with the whole, this is not a rig thing, when producers or whoever might think that just the skeleton with the skin mesh is the rig, and you have so much more to do when you have to build Maya rig controls and IKs and FKs and splines and all these things that aren't they don't understand as part of the schedule and take you a lot longer than that process, for sure.
Can I ask a question?
To me or to who?
Mike.
Okay, yes, please.
So you're talking about space switching, and one of the examples was dropping the weapon on the ground.
Yes.
So I've worked on games where the weapon is a child of the hand, and I've also worked on games where the weapon is a child of the root.
Yes.
And the disadvantage, of course, to the root is then you can't really do some torso up blending because the weapon gets left behind when they're doing swings and whatnot. When you have it as the child of the hand, you get ridiculous compression artifacts when you drop it on the ground and it's doing this on the ground. Do you have any suggestions for getting around that sort of limitation?
It depends a little bit on the engine you're using. So on Halo Wars, the weapons followed a bone that were a child of the hand. We definitely hit that scenario of like one of the characters gets shot, the gun flies off, it lands on the ground, and the character's rolling and it's counter-animating and it's going all over the place. We were using Granny runtime, so that's an animation engine. And that had a nice feature where you could specify the compression rate on a per bone basis. So then at export time, we would detect, as a part of the export process, we'd look at the grip bone that the weapon's attached to, and if that starts to, the length of that starts to deviate away from the hand, we would then say, okay, take this bone and all of its parents, and we would lower the amount of compression that would be applied to it. So the rest of the character would be highly compressed, apart from that chain, and that's on a per animation basis. So that saved us on that one. When you don't have a functionality like that, it's definitely a lot trickier, and it then depends on the kind of game. If you're dropping stuff a lot, then I think having that grip bone to be actually a child of the root probably makes more sense. But yeah.
All right, I'm actually going to let Izzy take this one on. This is also Add a Bag of Candy. How can an animator better communicate with a rigger to create great characters?
It's a really loaded question. Can you repeat it?
How can an animator
Yeah.
better communicate with the rigger to create great characters?
Great characters? That's really subjective. Well, as far as like creating the best rig for that character, I guess like how I would approach it is like an iteration process. Like I would build something and then you would test it and just try to break it. Like we have range of motion tests, as I'm sure all of you do, and then make a range of motion test for me, and then I can run the rig through that range of motion test, and then I give it back to you, and then you could keep continually breaking it, and I'll try to like improve it over time. Yeah, if that answers that question.
Animators are really, really good at breaking rigs.
Yeah.
That's a good test.
Exactly.
Cool, thanks. Again, at a bag of candy, what is the most difficult character you've worked on? I'm going to take this one, actually.
Okay.
I have two answers for this. The first was kind of a character. It was the parachute in Just Cause 3. It was a pain in the ass. I had to rig the canopy with joints. We didn't have any sort of cloth simulation on it. I mean, the animator that we had on it was really, really great. Thanks, Ricky. And the canopy was really, really tough to just set up, and it took a lot of iteration because of just, I mean, you can't really crush joints like a canopy into a real like wiggly cloth simulated thing. But yeah, in the end, I think it all worked out for us, and it looked really, really slick. And my second one was at my time spent at 38 Studios, rest in peace. When I was working on the MMO, there was a Naga that was like a serpent lady with a tail, and like just having to try and get a spline IK that the animator could use was, I mean, there was really no workaround, and it really didn't work out so well. Thanks, Tim. I assume these are more questions. The Naga, just the long serpent-like tail on this like Medusa-like creature was just really tough, and the animator was having trouble trying to pin it down and get good realistic, well, not realistic, but like good looking sort of just wiggliness and all that, and it was just the biggest pain. And then that character got cut anyway, and then the game got cut anyway. So, yeah, I mean, well, the studio got cut too. But yeah, so those were the two most difficult characters I've ever worked on. Okay, let's see. Does anyone want to take this one on from @censored? What kind of game characters are the hardest to create? Are there genres that are harder than others? Does anybody want to take that? I mean, I can say for genres, definitely sometime like a fantasy kind of game works, isn't necessarily the easiest thing to work with because you're working with crazy things like I just mentioned, the spline IK stuff. Again, on 38 Studios, I rigged a tree ant kind of creature with like really tentacly tree roots that was like in the ground. I believe the animator on that's named Skylar Sura, so thanks Skylar for making my rig look super, super awesome if you're watching. But yeah, like any fantasy type characters and anything tentacly, I think. Like if you have like an octopus or something, like I think if you go back and look at Finding Dory, there's a blog post online about the octopus. And it was like a super technical challenge. I think they had like 20 riggers or animators.
Oh, yeah.
Like,
I think they did a lot of R&D on that too.
yeah, they did a ton of R&D. So that's actually a cool article if you want to check out something that's like super difficult to work on.
I'd probably add to that as well. Anything you can't find reference for. So as you mentioned, something from a fantasy setting or genre, or things that has super complicated setups, or even mesh that doesn't allow you to deform properly. Like things are really bulging and really tight if it's a really large character, but you're limited with the amount of joints that you have, because with a game engine, typically you are. You have to try and be inventive with that. But yeah, things you can't find reference for, then you have to speak to the concept artist or the modeler to try and work out how did they envision it move. Because at the end of the day, it would have been designed or made to some degree with motion in mind. So you'd speak to the artist, the animator, the modeler, and the concept artist, and you try and work out together how is this supposed to move if you can't find any reference for. And that's always a challenge. Yeah.
Let's see. Oh, again, add a bag of candy. You're really busy tonight, add a bag of candy. What technological advancement has had the biggest impact on your work? Wow, Lee's eyes just lit up.
I think.
Yeah.
Oh yeah.
All right.
Yeah. So I think probably is CPU and GPU, the amount of power, the amount of RAM you can have, because nowadays we can have heavier rigs than what we used to be able to have before, which means the animators are a lot happier with some cooler functionality, even large joints, not large joints, higher joint count. That easily, for me, has made the biggest difference. If I was super limited to the amount of constraints I could put in, or the type of constraints, or the number of joints, even now, it would make a huge difference, just during runtime. Plus then tools, trying to be able to batch things or trying to be able to apply certain behaviors, it would be a complete nightmare without the power of computers that we have now.
I work for a VR company, so the VR stuff, anything VR related, we would not exist without VR. So that's a technology I'm really excited and working games in. We're like the cutting edge. We're kind of like where mobile games is, where we have to be very, very conscious about how many assets we put in our performance budget. So yeah, Oculus and Vive for me.
I think as well, like less from a rigging specific stuff and more from a tools, just the utilization of Python and Qt across all different applications, right? It opened up a lot of doors in terms of pipelines and cross-application workflow. That's made a massive difference.
Yeah, actually, for me, the Qt has been huge for me, as well as PyML. Actually, I've been using PyML almost exclusively these days, and like just having these advances in just like within Maya has been really awesome for workflows and speed and all sorts of scripting.
I would absolutely almost as well add motion capture. Purely, we wouldn't be able to produce the amount of content that we can if we didn't have motion capture. And Pete, who sorts the mocap stuff side, he's a wizard. Saves him so much time.
Sounds like Rich has something too.
Oh, yeah. I was going to talk about the Python PyQt.
Yeah, absolutely.
Sorry, PyQt. We built a tool that was actually, because we have a pipeline where we use Max and Maya, and we built a tool that was able to run both in Max and Maya and standalone without Max or Maya with the same UI.
Cool. All right, we got a couple more questions here that Tim ever so gently put into my shirt. What sets a demo reel apart from a typical rigging demo reel, and how can we make our reel stand out? Oh, I'm sorry, that's from that's a mesh of words, at Alondra Paco. I'm sorry if I butchered that handle. But yeah, so what sets a demo reel apart from a typical rigging demo reel, and how can somebody who is looking to get into a technical animator type role or a rigger role make their reel stand out?
One thing that we always talked about when we were looking for riggers is something we've never seen before. If you see a reel where, characters moving their FK joints around and it's, something that you could have done 15 years ago, it's not that exciting. We want to see a character wrapping around a tree. I don't want to make it sound that we're looking for the moon, but just something that we haven't seen before. And of course, like with any reel, put your best stuff first. Wow us, so we keep looking. If we see mediocre stuff and the good stuff's at the end, we'll never see it.
Oh, did you want to go, Brian? Oh, for me, it's quality over quantity. I want to see a couple things that you're really proud of, and not litter your demo reel with maybe stuff from 2 years ago that you're not as proud of. And of course, put like your best stuff first. But even if you have 1 or 2 pieces that you're really proud of, show that. And then when you apply to a job, make sure you cater your portfolio and your demo reel to the job you're applying to. Because if you have, like you're applying to a character, I'll just take character art. You're applying to a character art job, but you have environment art, that's not relevant. So make sure the stuff that you put on your resume. I actually made a website per job that I applied to. So I'll have a portfolio per job. And so it'll be like my, World of Warcraft like portfolio or like Servio's portfolio. So then it's very, very clear, like you don't want to click around. Like we don't want to click around and look for your YouTube video. We want to just see it right there. So make sure everything's clean, please.
Okay. All right. We have one final question, I believe. It's from at Chopsoki. I think so, maybe. Ever use Ragdoll in DCC to help animation creation, i.e. character knocked over, character gets back up? I haven't used it myself. I mean, I only use Ragdoll in games. So have you?
Yeah,
really?
Yeah,
okay, great.
Yeah, absolutely. We have, again, anything that's going to speed up your animation. At the end of the day, even with Ragdoll, you're not going to get the final result from that. So don't expect it to give you everything.
And you bake it out.
Exactly. And so it's got to work with what you have, and then you always have to do cleanup anyway. But if it helps you get to what you want, your end result, then absolutely. Yeah.
Cool. Anyone else? No? Good. All right. I actually want to fix one thing, I think, when I said thanks, Ricky, on the parachute for JC3. I think Alex actually animated that. So sorry, Alex, if you're watching. I believe he did. And now if I got both of them wrong and there's somebody else, I just completely screwed up. Yeah, I think we're done. I mean, thanks, guys, for hanging out, and thanks for watching us. As you can see on the screen, I think, all of our Twitter handles. If you want to reach Mike, you can tweet at Lee and tell him that you want to talk to Mike. I believe that's how it will work. Yeah, you guys, do you sit next to each other? Yeah, that's his PA. Lee is his PA. So yeah, thanks a lot, guys. Thanks for watching.